Hi guys, and welcome to this video. In this video I'm going to show you how to sketch some cubic functions. Now there's a few little bits and pieces you need to work out first before you can actually draw in a cubic function. So let's go through those things now. So I've got an example here. So for the cubic function y equals -2, x plus 3, x take 2, x take 1. X take 5, sorry. Find the coordinates of any points where the graph of the function cuts the x-axis and the y-axis. All this really is a fancy way of saying, can you tell me what the x-intercepts are and what the y-intercepts are? So to find the x-intercepts, we're going to let y equals 0, okay? And to find the y-axis, where it cuts the y-axis, or our y-intercepts, we're going to let x equals 0 for this particular function here. So let's do that right now. So for this one here, my x-axis here, y equals 0. So let's make that, 0 is equal to -2, x plus 3, x take 2, x take 5. All right. Now, people always tell me, what do I do with this -2? This -2 is really annoying. It's really putting me off. I don't know what to do with that. Now, let's have a think. Let's try to get rid of it, right? Let's try to put it to the other side to get rid of it. If I divide the whole thing by -2, and this side by -2, what's 0 divided by -2? Is that not 0? So in fact, we don't even have to worry about the -2. The -2 is just there, just to kind of bother you, just to be annoying. I'm just actually going to get rid of it. I'm going to erase it because it's really not really useful at all. Okay, so essentially you can just write it like that. You don't even have to include the -2 because the -2 can just be divided out and no longer becomes a problem. So null factor law says we have one of those brackets have to equal 0. So let's have a look. So x plus 3 equals 0. So x equals -3. X take 2 equals 0, or x equals 2. X take 5 equals 0, or x equals 5. So here's my roots. I've got -3, 0. 2, 0, and then 5, 0. All right. So let's do my next bit. Let's find my y-axis intercept. So I'm going to go y equals -2, 0 plus 3, 0 take 2, 0 take 5. So basically I'm just multiplying by all these numbers here. Alright, so I've got -2 times by 3 times by -2 times by -5. So -2 times 3 is -6. And then you've got this is -6 here, I'll write it here. And then I've got -2 times by -5 is just +10. -6 times 10 is -60. So it's telling me that my y-intercept is 0, -60. Okay. So now I've got these points. This is really good. We're on a really good start. So for my sketch, I'm going to know some really important points. I'm going to know my roots. I'm also going to know my y-intercept. Now let's see if we can figure out what is the graph actually going to look like. How am I going to know if it's going to be going up in which direction, which one's going to go down? So here's that next bit here. So let's have a look. Describe the behavior of the y values as the x values become increasingly large positively. So let's have a look. My graph here, I'm just going to write it here so that way I don't have to keep scrolling up. Okay, so you can see here, okay, so if I let x equal, I don't know, 100 or something really, really big, 1,000, million, if I let them go into these brackets, they're just going to be big numbers. So I'm going to have like 98, 95. Now all those numbers multiplied together are going to be big numbers. But as soon as I multiply it by -2, that's going to become a really negative big number. Does that make sense? I'm going to have these numbers all are big, but then as soon as I multiply it by negative, it's just going to change the sign to be a negative, and it's going to be a really big negative number, like a -1,000 or negative whatever it's going to be. Now that means when x approaches infinity, that's how we write it, or as it gets bigger, essentially, if we let x equal a really big number, y is actually going to become really small. It approaches -infinity, because the bigger this negative number is, so for example, you could say -1 is bigger than -1,000. as soon as that number gets bigger and bigger and bigger, it's going to slowly go towards negative infinity. It's going to keep, if you keep making that number bigger, so like negative a million is closer to infinity than negative 1 is. Okay, so it's kind of an abstract thought to really think about, right? So as x, in this particular case, as x gets bigger, because you've got a negative number here, is going to make y, your answer for this whole function for y, is going to be smaller and smaller and smaller. Okay, that's how it works. You're really just assuming, let x be a really big number. As soon as you take that really big number and divide it by, multiply it by a negative number, it's going to become a really big negative number. So it is a bit hard to explain. We'll keep going. We'll do a few more examples, but that's kind of the gist I want you to get at. Okay, so as x gets bigger, y equals negative infinity. Now, if you think about on a quadrant or a grid, Cartesian plane, as x gets bigger, so this is x, it's getting bigger on this direction, y gets closer to negative infinity. Now, this goes towards positive infinity because, you know, you have your positive axes here and your negative axes here. That means in this graph, it's actually going to end up in this quadrant down this way because as x gets bigger, y gets smaller. So in fact, it's going to go in this direction. Now, this is important for later on. Just note it. Just think about it. Let's do the next one. So we're going to, what happens when it goes large, increasingly large negatively? So in this particular circumstance, again, if we go back to our rule, if we let x equal a really big negative number, let it equal negative 100, negative a million. Okay, so a negative times a negative is a positive. That positive times by a negative becomes a negative. That negative times by a negative number is positive. So it's going to be increasingly positive, right? That's a way to think about it. Because I know it says it's like 3, negative 2, and negative 5. But those become so insignificant in comparison to this big number. Let's think about an example. So if I let x equal 1, 1 plus 3, you know, is relatively big. And this plus 3 is important because it changes the number dramatically. But if I have a million, for example, plus 3, this million and 3, that 3 is no longer significant. So the bigger the number, the more insignificant these plus 3, negative 2, take 5 become. And they soon eventually just become invalid, and there's no real point of having it there. So that's why it's really kind of important to kind of view it in a very abstract way. And that's why I say, imagine if you just let those brackets be really, really big negative numbers, like a million, negative a million or negative 1,000, and you're just basically multiplying negative numbers. You're going to have a negative times by a negative, which is a positive. Positive times by a negative is a negative. And negative times a negative is a positive. So as x approaches negative infinity, y is going to approach infinity. So again, if you think about Cartesian plane, as x gets smaller in this direction here, y is getting bigger that direction. So in fact, that's the direction we want to be going. Okay, here's the big deal. We're actually going to answer the question now. We've done all this work to just be able to sketch a graph. Can you believe it? So I'm going to draw a really big Cartesian plane. And the first thing to do is to put in your roots and intercepts. So we worked them out before. Do you remember that? All that time ago. So I'm going to put in negative 3, 2, and 5. So negative 3 is going to go here. 2 is going to go here. 5 goes at the very end here. Those are my roots. So I need to know that my graph that I draw is going to go through those points. Okay. My y-intercept, remember, negative 60. Negative 60 all the way down here. Let's just say, it's not to scale. It's just very, very vague. Okay, it's very rough. It's just a sketch. It's not perfect. And that's okay. Okay. Now, we did this bit earlier, and you might be thinking, why is this important? I don't get it. It's to tell us what the graph's going to look like. Because how am I meant to know if the graph is going to look like this, or if it's going to look like that? It can look like any of those ways. They're still quadratic. They're still cubic functions. They're still the same. I just need to know which way it's going to go. Is it going to go that way or this way? It's hard to think. That's why we have to think about this two sections here to help us, right? So as mentioned before, as x gets bigger than as x gets bigger, y gets smaller. So it's telling me as x gets bigger, I'll use a different color. As x gets bigger, y is smaller. So it's going into this quadrant here, isn't it? Like I mentioned before. Oops. Meant to erase it. There we go. Right, x gets smaller. And then as x goes towards negative infinity in this direction here, it's going to get bigger. So I'm going to expect my graph to slowly go up this way. That tells me it's going to look through, like, it's going to look like this one. Okay? So let's finish off the details. I'm going to make sure it goes through all these points. Now, there could be several interpretations of this, by the way. Like, I'm just drawing one of the several. Oh, that's a bit big. I'm not very good at drawing on my iPad like this. Oh, please do a better job than that. But it can look like that. There's a few different options you can make it look like. You could have made it look like this. It could have gone way past there and just gone through the points. And it could have gone really, really high before, like that. It could have gone just through there and then had a turning point down here, then up and just maybe a little small one. Ooh, these are rough times, guys. Hopefully you get my drift. But either way, it doesn't matter where your turning points are, as long as they go through those main points that we found, okay? And make sure that they're as smooth as possible. Please don't do this whole system thing and just like sketch it and like really roughly do it. Don't do that. We don't like that. Try to make it as best as you can and nice as possible. And what's really good about labeling these bits is to actually give you coordinates. So let's try this again. Oh, I had an effort. The effort was there. You win some, you lose some. Anyway. Not like that. Oh no. Anyway, I hope you get my drift. But yeah, as long as it looks something like that, you've had your main points kind of pointed out. Yeah. Okay, so as long as you've got that right and it looks something like that and you've got the direction correct, you're on the right track. I hope this wasn't too confusing for you. Have a look at the next video for more information.